Hey everyone, welcome back for another deep dive. Today we're going to be tackling something pretty mind-blowing.
I like those. Mind-blowing. Sign me up.
Yeah, so it all starts with Tesla, Nikola Tesla.
Okay. I know the name, of course, but...
Yeah, the guy was a genius, totally ahead of his time. But
Right, but kind of eccentric.
yeah, he had some interesting ideas.
That's putting it lightly.
But anyway, today we're looking into one of his more, shall we say, out there ideas.
Okay, lay it on me.
So Tesla was obsessed with the numbers 3, 6, and 9, like really obsessed. He thought they held the key to the universe or something.
That is pretty out there.
It is, but we found this research paper that tries to make sense of it all using math. And get this, it actually kind of makes sense, in a weird way.
Okay, now I'm intrigued. Mathematical basis for Tesla's obsession. I'm listening.
So to understand this whole thing, we need to step back and think about numbers in a different way.
Okay, I'm ready.
We all use the base 10 system, right? 10 digits, 0 through 9, and we build all our numbers from there.
Right, that's just how we count.
Exactly. But what if we used a different base? Like, what if our number system only had 8 digits?
I never really thought about that.
I know, it's kind of mind-blowing.
So how does this tie back into Tesla and his magic numbers?
Well, the paper delves into this thing called digital roots.
Digital roots, is that like a computer thing, or...?
No, it's actually pretty simple. It's basically where you add up all the digits in a number, and you keep doing that until you get a single digit.
Okay, I think I get that. So, like, if you have the number 64, you add 6 and 4, you get 10. Add 1 and 0, you get 1. So the digital root of 64 is 1.
Exactly. You got it.
Okay, cool. So what's so special about digital roots?
Well, the paper looks at this specific sequence of numbers. It starts with 1, then you double it to get 2, then double again to get 4, then 8, 16, 32, and so on. Each number is double the one before it.
Okay, I see. Keep doubling.
Now, if you calculate the digital root of each number in that sequence, you get a repeating pattern. 1, 2, 4, 8, 7, 5.
1, 2, 4, 8, 7, 5. Got it. But I don't see the connection to Tesla yet.
But look closely. What's missing from that pattern?
It's just 1, 2, 4, 8, 7, 5 over and over.
Exactly. There's no 3, 6, or 9. And here's the big reveal. That's because we're using a base 10 system.
Wait, what? You're telling me those numbers are missing because of our number system?
Yep. According to this paper anyway, it suggests that if we use a different base system, those numbers might not be missing at all.
Wow. Okay, so like in a base 8 system, would the pattern include those numbers?
Not necessarily. The paper gives the example of base 8, and that sequence has a different pattern. 1, 2, 4, 1, 2, 4, and it just keeps repeating like that.
So no 3, 6, or 9 there either, but it's a much simpler pattern. Interesting.
Right. And in base 9, it gets even weirder. There's no repeating pattern at all.
No pattern at all. That's strange.
It is, right. So what this suggests is that maybe those numbers that seem so significant to Tesla, they're not actually universally special. Maybe it's just an artifact of our base 10 system.
So Tesla wasn't wrong. He was just thinking in a different system. Or maybe we're the ones thinking in the wrong system.
Now you're getting it. It's like our entire understanding of math, maybe even reality itself, is based on this arbitrary choice of base 10.
Okay, my mind is officially blown. So what happens if we look at other base systems? I mean, does everything change? Or are there some things that are just like true no matter how you count?
That's a great question, and that's what we're going to dig into next. Okay, so where do we go from here? What other mathematical mysteries can we uncover with these different base systems?
Well, the paper takes this idea and applies it to something a little more visual.
Okay, I'm intrigued. More visual, how?
Polygons.
Yeah.
You know, shapes.
Yeah.
Triangles, squares, pentagons, all that.
Right, got it. Polygons.
And specifically the sum of their interior angles.
Ah, okay. Like how all the angles inside a triangle add up to 180 degrees.
Exactly. And in our familiar base 10 system, there's a really neat pattern.
Okay, what is it?
No matter how many sides a polygon has, the digital root of the sum of its angles will always be 9.
Really? Let me test that. A square has 360 degrees. 3 plus 6 plus 0 is 9. Okay, that works. What about a pentagon?
Go for it.
5 sides. Okay, so the angles add up to 540 degrees. 5 plus 4 plus 0, that's 9 again. Wow, you're right. That's pretty cool.
It is, right. But it gets even more interesting when we jump into those other base systems.
Okay, now I'm really curious. What happens to those angles in, say, a base 9 universe.
So picture this. In a base 9 world, a right angle wouldn't be 90 degrees, it would be 80 degrees.
Whoa, okay, my brain is trying to wrap itself around that. 80-degree right angles, that's
But
wild.
and a circle wouldn't have 360 degrees, it would have 385.
So everything would just be kind of shifted, but would the angles and polygons still add up in some predictable way?
They do. The pattern just changes a bit. Instead of the digital root always being 9, it would always be 8 in a base 9 system.
Huh. So the specific numbers are different, but the underlying pattern is still there.
Exactly. And the research paper actually proves this mathematically. It says that in any base n system, the digital root of a polygon's angle sum will always be n minus 1.
So even though the individual numbers change depending on the base system, there's this sort of deeper mathematical truth that holds true across all of them. That's kind of amazing when you think about
It
it.
really is. It suggests that there are these fundamental mathematical principles that exist independently of our chosen number system.
It's like maybe we're just scratching the surface of what's really out there, mathematically speaking. What if there's a whole universe of math that we haven't even discovered because we're so stuck in our base 10 way of thinking?
It's a fascinating thought, isn't it? And it makes you wonder if maybe Tesla was onto something with his fascination with different numbers and patterns.
I mean, he was clearly brilliant, even if some of his ideas were a bit out there. Like, remember that whole thing about harnessing free energy?
Yeah, that was definitely one of his more controversial ideas. And while the concept of free energy is intriguing, it's important to remember that there's a big difference between a theoretical possibility and a practical application.
For sure. But even setting aside the more speculative aspects of Tesla's thinking, I think this whole deep dive has been incredibly thought-provoking.
I agree. It really challenges us to question our assumptions about something as fundamental as our number system.
And to think, we started with just 3 little numbers, 3, 6, and 9.
And look where we've ended up. It just goes to show you never know where a simple question might lead you.
Absolutely. And speaking of questions, this whole conversation has definitely sparked a bunch of new ones for me. I'm especially curious about Tesla's ideas about resonance and vibration. He believed that everything in the universe is connected through these invisible patterns of energy. What do you think about that?
That's definitely getting into some pretty deep territory. But it's certainly an intriguing idea. Maybe that's something we can explore in a future deep dive.
I'd love that. But for now, I think we've given our listeners plenty to chew on. This whole concept of different base systems and the idea that mathematical truths might not be as absolute as we think, it's definitely a lot to process.
It is. But it's the kind of mind-bending stuff that makes exploring these topics so rewarding. It makes you realize just how much there is still to learn and discover about the universe.
And that's what the deep dive is all about, right?
Exactly. Always questioning, always exploring.
So to all our listeners out there, we encourage you to keep that spirit of curiosity alive. Keep asking questions, keep digging deeper, and who knows, maybe you'll be the one to unlock the next big secret of the universe.
And if you do, be sure to let us know. We'd love to hear about it.
Absolutely. Until then, thanks for joining us on this incredible journey. And remember, stay curious. I think it's really amazing how Tesla, even with some of his more, I guess, unconventional ideas, always seemed to come back to this like awe and respect for how elegant and interconnected everything is.
Yeah, for sure. Even if you don't buy into all of his specific theories and stuff, I think that's something we can all appreciate. That idea of like looking for the patterns and connections, seeing the bigger picture, not just focusing on the individual parts, but like how it all fits together.
Totally. It's almost like he was trying to find a hidden language or code that could like explain the whole universe.
Well, who knows? Maybe he did catch a glimpse of it.
Yeah.
Even if we haven't fully cracked the code yet, I think the process of searching, of pushing the boundaries of what we know, that's got to count for something, right?
Definitely. So where does all of this leave us? I mean, what can we, the non-mathematicians, the non-physicists, take away from all of this? Like, why should we care about these different base systems and stuff?
Well, I think the big takeaway here is to remember to keep an open mind. We get so used to seeing the world in one specific way that we forget there might be other ways of looking at things.
Right, like we're stuck in our own little bubble.
Exactly. And this whole exploration of number systems really highlights that. It shows that even something as fundamental as math can be approached from multiple perspectives, that maybe there's not just one right answer.
It's like that old saying, if all you have is a hammer, everything looks like a nail.
Right, totally. We tend to approach problems with the same tools and frameworks we're familiar with. But what if we need a totally different set of tools? a whole new language to really understand how the universe works.
It's a pretty mind-blowing concept, right? That maybe our current way of thinking is actually limiting us.
Yeah, it really makes you think.
Yeah.
And I think that's where curiosity and a willingness to question what you think,
Hmm.
that's where the real magic happens.
So this deep dive, it's not just about math, right? It's about encouraging everyone to look at the world with a bit more wonder and a little less certainty.
I like that. Look at the world with more wonder.
This whole conversation, I mean, it's been a wild ride. We started with some seemingly random numbers and ended up questioning, like, the nature of reality itself.
It has been quite the journey. And it's been awesome exploring all these ideas with you.
Same here. And to all our listeners, thank you so much for joining us on this deep dive. We hope you found it as mind-expanding as we did.
Absolutely. And remember, keep that curiosity alive. Keep asking those big questions. Keep exploring. You never know what incredible discoveries might be waiting just around the corner.
So well said. And hey, if you happen to stumble upon any groundbreaking insights inspired by Tesla and his theories, we'd love to hear about it. Until next time, everyone, stay curious.